Have you ever just stopped and wondered about the basic rules of our reality? You know, the ones that control everything from a simple tossed ball all the way up to the dance of the planets? Well, today we're cracking open the original rulebook for the entire universe.
I mean, really think about it. Why do things always fall down? Never up, never sideways? And what is this invisible tether that's holding the moon in orbit, stopping it from just flying off into deep space? For literally thousands of years, these weren't just simple questions. They were some of the biggest mysteries humanity ever faced. Everybody knew what was happening. Apples fall, the moon circles, but nobody could explain why. It was like the universe was playing a game with a secret set of rules. That is, until one person came along and, with just pure genius, decided to write it all down. And that person, of course, was Isaac Newton. The rule book he wrote would become the absolute foundation for how we understand the cosmos today. So let's get into the story of that book and the ideas inside that completely changed the world. So who was this guy? Well, Isaac Newton was an English scientist, a physicist, and mathematician who in 1687 published his masterpiece, the Principia Mathematica. And look, this wasn't just some other book. It's pretty much considered the single most important scientific book ever written. And here's a fun fact for you. The project was so huge and expensive that his friend had to pay for it. And that friend was Edmund Halley. Yeah, this same guy from Halley's Comet. So, what was so revolutionary about this book? Well, Newton started by laying out 3 beautifully simple laws that explain how and why things move. These 3 laws are the absolute bedrock of all physics. He broke it down into 3 clean steps. First, the law of inertia, then the law of force, and finally, the law of action-reaction. Once you really get these 3, you start to see the entire world a little differently. So let's take them one by one. Okay, the first law is all about something Newton called inertia. And honestly, the easiest way to think about it is just objects are lazy. At their core, they just want to keep doing whatever it is they're already doing. The official definition is this: an object at rest, like, say, a golf ball sitting on a tee, is going to stay at rest. And an object in motion will stay in motion, just cruising along, unless some outside force comes and messes with it, like a golf club or even just air resistance. That stubbornness, that resistance to changing what it's doing, that is inertia. Right, so if objects are lazy, how do you get them to change what they're doing? You have to apply a force. You have to push them. And the second law explains what happens when you do. It's actually super intuitive. If you push something, it accelerates. And if you push it harder, it accelerates more. Simple as that. This brings us to probably the most famous equation in all of classical mechanics. Force equals mass times acceleration. F equals ma. Now, what this formula tells us is that it's not just about how hard you push. The object's mass, how much stuff it's made of, is a huge part of the equation. It takes way more force to get a heavy bowling ball accelerating than it does a light tennis ball, right? This is the core principle of how things move. Newton's third and final law of motion. This one can be a little bit of a mind-bender at first, but it is happening literally everywhere all the time. It just says that forces never exist on their own. For any push, anywhere, there's always an equal and opposite pushback. The law is simple. Every action has an equal and opposite reaction. So when you lean on a wall, that wall is pushing back on you with the exact same amount of force. When a rocket shoots hot gas downwards out of its engine, that gas is pushing the rocket upwards with equal force. They're always a perfect pair. Same strength, opposite directions. Here's a great example, a boxing match. When one boxer's fist hits another's jaw, the force felt by the jaw is exactly the same as the force felt by the fist. They're an action-reaction pair. So why does one person get knocked out? Well, it's just a question of which part of the body, the jaw or the hand, is better built to handle that force. Okay, so Newton laid out the rules for how things move here on Earth. But his real genius didn't stop at the ground. He looked up at the sky, at the moon and the planets, and he had a wild thought. What if these rules apply to everything, everywhere? And the legend goes that his biggest breakthrough, his greatest leap, came from something totally normal: watching an apple fall from a tree. He started to wonder, if a force is pulling that apple down to the ground, what if that same force reaches up much, much higher? And this was the big aha moment. Newton realized that the force pulling the apple to the ground was the exact same force that was constantly pulling on the moon. You see, the moon is basically always falling toward the Earth, but it's also moving sideways so fast that it just keeps missing us, and that miss is what creates its orbit. It's the same force, just acting on a totally cosmic scale, and that led him to his law of universal gravitation. And here's the part that's truly profound. It says that any two objects with mass anywhere in the universe are pulling on each other. That means you are gravitationally attracting the chair you're in, and the planet Jupiter, and even a star in another galaxy. The only reason we only notice Earth pull is because the force gets way stronger with more mass and way weaker with more distance. Now, Newton's work was absolutely revolutionary, but like all great scientists, he wasn't just working in a bubble. He was building on what others had already discovered. You can kind of think of it like a big scientific relay race. First, you had Copernicus, who suggested maybe the Earth isn't the center of everything. Then came guys like Galileo, who studied motion and found evidence to back that up. They all helped figure out what was happening. But it was Newton who finally showed up and provided the math to explain why it was all happening. And Newton himself said it best. In a letter, he wrote this incredible, famous line, basically admitting that his amazing view of the universe was only possible because he was able to build on the incredible work of the scientists who came before him. So with these laws, we could suddenly predict the movement of planets with incredible accuracy. Newton basically gave us the user manual for gravity. He explained how it worked, almost perfectly. But there was one huge question his rulebook just couldn't answer. What is gravity, actually? What is this strange force that seems to act across totally empty space?
And that question, what is it, would just hang in the air for over 200 years, waiting for the next great giant of physics to show up and write a completely new chapter. Because it turns out, gravity isn't a force in the way Newton imagined at all. But that, well, that's a story for another explainer.